students, welcome to the group sections. Session 4, I think this is one. Okay, and so last class I discussed some important properties of order of an element. Important properties of order of an element is that fourth property we discussed in last class is if order of an element A is m and a to the power of m is e, so then definitely n divides m, or n is a divisor of m. So our m is divisible by n, m is divisible by n. ಅಂದ್ರೆ ಅದರ ಮೀನಿಂಗ್ ಏನು? ಸೊ ಇಷ್ಟನೇ ಅದು ಹೇಳುತ್ತೇನೆ ಏನಂದ್ರೆ ಒಂದು ಎಲಿಮೆಂಟ್ ಇದೆ ಎ ಅಂತ. ಸೊ ಎನ ಆರ್ಡರ್ ಆಫ್ ಎ, ಆರ್ಡರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ ಎ ಈಸ್ ಎನ್ ಇದ್ರೆ, ಸೊ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಏನ್ ಬರುತ್ತೆ? ಇ ಬರುತ್ತೆ. ಸಪೋಸ್ ನಿಮ್ಗೆ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಂ ಆಗ್ದಾಗ್ಲೂ ಇನೇ ಬಂದ್ರೆ, ಸೊ ಇವಾಗ ಎನ್ ಏನ್ ಮಾಡುತ್ತೆ? ಎಂ ಅನ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. ಸೊ ದಟ್ ಎಂ ಈಸ್ ಡಿವಿಸಿಬಲ್ ಬೈ ಎನ್ ವೆನ್ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಂ ಈಸ್ ಈಕ್ವಲ್ ಟು ಇ. ಓಕೆ, ಸೊ we take a note, or the conclusion of this theorem is, so by the above properties, suppose if you take a to the power of m is equal to e, so ಯಾವುದೋ ಒಂದು ನಂಬರ್, ಒಂದು ಇಂಟಿಜರ್ನ, ಒಂದು ನ್ಯಾಚುರಲ್ ನಂಬರ್ನ ಪವರಲ್ಲಿ ಹಾಕಿದಾಗ ಸೊ ನಮ್ಗೆ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರ್ತಿದೆ ಅಂದರೆ ದ ಆರ್ಡರ್ ಆಫ್ ದಟ್ ಎಲಿಮೆಂಟ್ ಶುಡ್ ಬಿ ಲೆಸ್ ದೆನ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು that index. So a to the power of m is e means order of a is less than or is equal to m. Order of a is less than or is equal to m. So ಎಲ್ಲೇ ಇರಲಿ ನಿಮಗೆ a to the power of some k is equal to e ಅಂತ ಕೊಟ್ಟಿದ್ರೆ we can write order of a is less than or is equal to k. ಹೀಗೆ ಬರೀಬಹುದು ಇದು. Okay, so it may be k, the order of a is k, or it may be less than k. Okay, has one more important property of the order of an element is that fifth property I wanted to discuss in today's class. If a and x be two elements of the group G, a is an element of G and x is another element of group G, then order of a is same as order of x, a, x inverse. Order of a is equal to order of x, a, x inverse. Okay, to prove this, order of a and order of x, a, x inverse are same. To prove this property, you take order of a is some integer m, n, and order of x, a, x inverse is some m. Okay, you consider, I'm just taking its proof. Take its proof as, let order of a is equal to n and order of xa, x inverse is equal to m. Order of xa, x inverse is equal to m. So now you consider xa, x inverse, you take to the power n, initially you take to the power 2, xa, x inverse to the power 2. So you see, so in groups, if a square is given, you can write that a square is a into a. Okay, a cube is given, you can write that is a cube is a into a. Okay, because we can't say that is an abelian group. Suppose AB is given, you can write AB. You can write AB as AB into AB. You can't write AB. Okay, AB square is given. Suppose ನಿಮಗೆ AB square ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. You can't write A square into B square. So because we don't know whether it is commutative or not. Okay, so this is wrong. You can't write this one. AB square can be written as AB into AB. ಅಷ್ಟು ಮಾತ್ರ ಬರೀಬಹುದು ಅಷ್ಟೇ. ಸೊ ಗ್ರೂಪ್ಸ್ ಅಲ್ಲಿ ಏನಂದ್ರೆ we are using groups and rings properties everywhere. ಬಟ್ ಅದಕ್ಕೆ ರೀಸನ್ ಯಾಕೆ ಅಂತ ಇವಾಗ ಲರ್ನ್ ಮಾಡ್ತಿದ್ದೀವಿ ನಾವು. B.Sc ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ, ಬೇಸಿಕ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ನಾವು ಅದು ರೀಸನ್ ತಿಳ್ಕೊಳ್ತಾ ಇದೀವಿ. ಸೊ many times you are using a into a is equal to a square, or ab square can be written as, generally in real numbers ab square can be written as a square into b square. But in real numbers, okay, it's no problem. But in case of that element is some matrices or some other else, so then we can't write like that. Okay, for that reason, so xa x inverse whole square is there. You can write that xa x inverse whole square as xa x inverse into xa x inverse. Okay, so you can write it is xa x inverse into xa x inverse. As here we can use the associative property, so that is we can grouping this in different way. So then you can write it is xa into x inverse x into a into x inverse by using associative property. So you can use associative property because G is a group, otherwise we can't use this property. Okay, we can't grouping in different ways like this. Okay, so which is equal to, since that x and a are elements of group G, so you can write x inverse into x is E. So if they are not the element of group G, we can't write x inverse into x is E. Okay, so xa into, this is an identity element E into a x inverse. Okay, so now if you operate an identity element with any one, you get the same. So xa into E is xa only. This is xa into a x inverse. xa into a x inverse. So because E is the identity element here, which is equal to x into a into x inverse. I am using associative property again. Okay, so we can grouping like this by using associative property. So then x into a into a can be written as a square into x inverse. A square into x inverse. Yes, this is xa x inverse xa x inverse square can be written as x a square x inverse. Suppose if you take xa x inverse cube, so then x a cube into x inverse we can write. So by using similar steps, we can write xa x inverse whole cube as x into a cube into x inverse. Like that, we can generalize this result. So similarly, it can be generalized as okay, so that is xa x inverse to the n is equal to x a to the n into x inverse, x a to the power of n into x inverse, which is equal to x into, as in the beginning we write that order of a is equal to n. Order of a is equal to n. If order of a is, then what is a to the power of n? A to the power of n is e. If order of a is n, so a to the power of n is e. So you write a to the power of n is e here into x inverse. This is because order of a is equal to n, which implies that a to the power of n is equal to e. Since order of a is n, so a to the power of n can be written as e. Okay, if you operate x with e, it gives x only, so it is x into x inverse. Again, x into x inverse can be written as e. So thus x a x inverse to the power n is equal to e. xa x inverse element ಗೆ ಪವರ್ ಅಲ್ಲಿ n ಹಾಕ್ದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರ್ತಿದೆ ಅಂದ್ರೆ ಆರ್ಡರ್ ಆಫ್ xa x inverse ಏನಾಗಿರುತ್ತೆ, it should be less than or is equal to n ಆಗಿರುತ್ತೆ. By using that above note or above properties, which implies that ನಾನು ಅವಾಗಲೇ ಹೇಳಿದ್ದೇನೆ order of a to the power of n m is e, then order of a should be less than or is equal to m, like that. So which implies that order of xa x inverse is less than or is equal to n. Okay, so that is, what is the order of xa x inverse? So we take that, we consider that order of xa x inverse is m, so that m is less than or is equal to n. That is, m is less than or is equal to n. You take this inequality is 1. Take this inequality is 1. So again, order of xa x inverse we consider it is m anta ತಗೊಂಡಿದ್ದೀವಿ. So take the statement, and also order of xa x inverse we consider it is m. Okay, so what it implies, xa x inverse to the power of m is e, xa x inverse to the power of m is equal to identity element e. Okay, so now we know that is here we generalize this result. xa x inverse to the power of n can be written as xa x inverse whole to the power of n can be written as x into a to the power of n into x inverse ಅಂತ ಬರ್ದಿದ್ದೀವಿ. Similarly, if you write xa x inverse whole to the power of m is equal to e, you can write this is x into a to the power of m into x inverse. So ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇಲ್ಲಿ you can write it is x into a to the power of m into x inverse is equal to e. So which implies that x into a to the power of m into x inverse is equal to, so in right hand side identity element is there, you write this identity element e as, ಬೇಕಾದ್ರೆ ನಾವು ಅದನ್ನ x into x inverse ಅಂತ ಬರೀಬಹುದು, because x into x inverse is e. And here you use the cancellation law, left cancellation law and right cancellation law. So for initially use right cancellation law, cancel this x inverse, so then remaining is x into a to the power of m is equal to x. So that is by using right cancellation law. I am cancelling this x inverse here. Cancellation laws holds in any group. Okay, so that is by using right cancellation law. Okay, so again by using left cancellation law, before that you write x into a to the power of m is equal to, you write this x is x into e, because if you operate identity element with x, then it gives x only. Okay, so here you use right left cancellation law and cancel this x and x, which implies that if x and x cancels, a to the power of m is equal to e. If a to the power of m is e, what it implies? So then we can write this is order of a is less than or is equal to m, which implies that order of a ಅಂದ್ರೆ ಏನಂತ ತಗೊಂಡಿದ್ದೀವಿ ನಾವು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ. Initially we consider that order of a is n, so n is less than or is equal to m. You take this is 2. ಎರಡು ನಂಬರ್ಸ್ ಇದೆ, ಒಂದು ಇನ್ನೊಂದಕ್ಕಿಂತ ಚಿಕ್ಕದಿದೆ, ಇನ್ನೊಂದು ಇದಕ್ಕಿಂತನೂ ಚಿಕ್ಕದಿದೆ. Is this possible? So a less than or is equal to b, b less than or is equal to a. Is this possible? It is possible only when that numbers are same. Okay, so here from expression 1 and 2, m is less than or is equal to n, and again we get n is less than or is equal to m. So m is less than n, m n ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಥವಾ n ಗೆ ಈಕ್ವಲ್ ಇದೆ, and n is less than or is equal to m, n m ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಥವಾ ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಇದೆ. It is possible only when they are equal. So that is n is equal to m. From 1 and 2 we get, from 1 and 2 we get n is equal to m. So that is what is n? n means that is the order of A. N is order of A. Order of A is equal to order of n. Order of A is equal to order of XA X inverse. That's it. Okay. So that is the required result. We proved this result. So order of A is equal to order of XA X inverse. Okay, I hope you understand this one. So next one more property is there. So that is let G be a group. G is a group and A is an element of G. A is an element of G. If order of A is equal to n and GCD of Mn is 1. We read this is GCD of Mn. I think you studied this number theory concepts in PU classes. If you write Mn is equal to 1 means GCD of M and N is 1. So, or we can say that M and N are relatively prime. Relatively prime. For example, I just write 4 and 6. GCD of 4 and 6 is 2. Greatest common divisor. GCD means greatest common divisor. Greatest common divisor of 4 and 6 is 2. Okay. So, and again you write GCD of 4, 3. GCD of 4 and 3 is 1. GCD of 4 and 3 is 1. Greatest common divisor of 4 and 3 is 1. ಎರಡನ್ನು ಡಿವೈಡ್ ಮಾಡೋ ದೊಡ್ಡ ನಂಬರ್ 4 ಮತ್ತೆ 3 ನ. So that is 1. 4 ಮತ್ತೆ 6 ನ ಎರಡನ್ನು ಡಿವೈಡ್ ಮಾಡೋ ದೊಡ್ಡ ನಂಬರ್. So that is 2. Okay. So GCD of 4 and 3 is 1. If GCD of any two numbers AB is 1, then we say that two numbers are relatively prime. Relatively prime numbers. So GCD 1 ಇದ್ರೆ ಅದನ್ನ ನಾವೇನು ಹೇಳ್ತೀವಿ relatively prime numbers ಅಂತ ಹೇಳ್ತೀವಿ. Okay. So here M and N are relatively prime because their GCD is 1. We write that M comma N is equal to 1. So then if so ಆ ಥರ ಇದ್ರೆ so then order of A to the power of M is equal to N. Order of A to the power of M is also N. Actually, what we say, order of an element A is N. Then order of A to the power of some K, order of A to the power of K is less than or is equal to order of an element A ಅಂತ ಹೇಳ್ತೀವಿ. That is one of the property. I think we proved that in the beginning. Starting ಹೇಳಿದ್ವಿ ಅನ್ಸುತ್ತೆ. Okay. So to prove this result, you take let order of, I don't know what is the order of A to the power of M is. I just take this some integer K. Let order of A to the power of M. Order of A to the power of M. We don't know, so it is K. Actually, what is order of A? Order of A is N. So then order of A to the power of M is K means K should be less than or is equal to N. That is one of the property. So we proved that in beginning. So by property, so that K should be less than or is equal to. So K is less than or is equal to N. So which implies that, so order of A to the power of M is K, then A to the power of M whole to the power of K, it should gives an identity element. Order of A to the power of M K ಇದೆ ಅಂದ್ರೆ A to the power of M ಗೆ power K ಹಾಕಿದ್ರೆ identity element ಬರಬೇಕು. Okay. So then which implies that A to the power of Mk is equal to E. A to the power of Mk is equal to E, which implies that A to the power of Mk is identity element. A to the power of n is what? A to the power of n is e. So this is because order of A is n. So A to the power of n is equal to e. Suppose A to the power of m is also e. So then definitely n divides m. Then definitely n divides m. So here order of A is n. So A to the power of mk is e, which implies that n definitely divides mk. So that is by using the property. You should remember the properties, otherwise it is difficult to prove the results. So this is by using property. Okay, so I am using this property here. So yes, you should give the reason in groups to what the steps you are writing. So all the steps you should give the reasons. Okay, by data. So what data they are given? M and N are relatively prime. By data, GCD of Mn is equal to 1. So that's, we write that n divides mk. n divides mk. ಅಂದ್ರೆ GCD of Mn 1 ಇದೆ ಅಂದ್ರೆ m n ಅನ್ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ, n m ಅನ್ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ ಅಂತ ಅರ್ಥ ಯೂಶಲಿ. ಓಕೆ, ಸೊ n, the product mk is divisible by n. Product mk is divisible by them. So what it implies? Either n divides m or n divides k. ಈಗ for example, 2 divides 6. So 2 divides 6, we can write that 6 as 2 into 3. What it implies? Either 2 divides 2 or 2 divides 3. Either 2 divides 2 or 2 divides 3. Okay, so like that n divides mk, which implies that and n and m and n are relatively prime. The GCD of mn is 1. What it implies? Which implies that n not divides m. ಈ 2 3 ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ. 2 3 ನ ಡಿವೈಡ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ 2 divides 2. It should divides at least one of this factor. ಇದರಲ್ಲಿ ಈ ಎರಡು ಫ್ಯಾಕ್ಟರ್ ಆಗಿ ಬರ್ದಿದೆ, ಇದರಲ್ಲಿ one factor ಡೆಫಿನೆಟ್ಲಿ ಇದರಿಂದ ಡಿವೈಡ್ ಆಗಲೇಬೇಕು. ಓಕೆ, so n not divides m, so then definitely n divides k. So which implies that n divides k. N divides k. Further, n divides k, and initially we write k is less than or is equal to n. K is less than or is equal to n. Is this possible? K ಅನ್ನೋ ನಂಬರ್ n ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ. n is the number divides k. ಈ ನಂಬರ್ n ಇಂದ ಡಿವೈಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇದು n ಗಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು, right? And here it shows that k is a number less than n. Is this possible? Sorry, it is not less than n. It is less than or is equal to n. Yes, it is possible only when this n is equal to k. This is possible, this condition is possible, so only when n is equal to k, which implies that k is equal to n. Hope you understand. K is a number, it is divisible by n, and k is less than or is equal to n. It is possible only when k is equal to n. ನೋಡಿ, ಒಂದು ನಂಬರ್ ಈಗ 2 ಇಂದ 6 ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ 6 2 ಇಂತ ಕಡಿಮೆ ಇದೆ. Is it possible? Definitely it is not possible. But it is possible only when these two numbers are same. So that is 2 divides 2 and 2 is less than or is equal to 2. Then it is possible. In other cases it is not possible. So n divides k and k is less than or is equal to n, which implies that definitely k is equal to n. Okay, so what it implies? If k is equal to n, what is k? K is the order of a to the power of m. So that is order of a to the power of m is equal to n. What is n? N is the order of an element a. So order of a to the power of m is equal to order of a. So that is the simple result. Yes. One more property of the same type. If order of a is equal to n, if order of a is equal to n, where a is an element of the group G, and so GCD of n and m, we don't know what is m. M is another integer. So the GCD of m and n is d. Then order of a to the power of an integer, that is a to the power of m, is equal to n divided by d. So if you know the order of an element a, we can easily find the order of an element a to the power of m only when when we know the GCD of n and m. We know the GCD of n and m, we can easily calculate the order of an element a to the power of m. Yes, I already discussed. If you write like this, d is equal to nm means the GCD, greatest common divisor of elements n and m, is d anta. Okay, so it shows that GCD of n and m is. So our intention is to find, or our intention is to show that order of a to the power of m is n by d. ಇದನ್ನ ತೋರಿಸ್ಬೇಕು ನಾವು, ಈ ರಿಸಲ್ಟ್ ನ ಇಲ್ಲಿ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ವಿ ಡೋಂಟ್ ನೋ what is the order of a to the power of m is. So you take an arbitrary element, so some k ಅಂತ ನಾನು ತಗೊಳ್ಳೋಣ. So let the order of a to the power of m is equal to k. You take that, let order of a to the power of k is equal a to the power of m is equal to k. As to prove this, let order of a to the power of m is equal to, take its proof. You take, let order of a to the power of m, we don't know, take it as k. So ಇದರ ಆರ್ಡರ್ k ಇದ್ರೆ a to the power of m ಗೆ ಪವರ್ k ಹಾಕಿದ್ರೆ, if you put the power of a to the power of m is k, then definitely it gives an identity element, because the order of a to the power of m is k. Yes, then what the data they are given? By data, the GCD of n and m is d. So GCD of nm is d. Okay, so what it implies? The greatest common divisor. So d is the greatest common divisor of m and n. So that means definitely d divides n, d divides m. So d divides n and d divides m. So this is the symbol we are using for d divides m. Divides, for the purpose of divides, hೀಗೆ ಬರೆದ್ರೆ d divides n ಅಂತ ಹೀಗೆ ಬರೆದ್ರೆ, okay, d divides n and d divides m. So d n ಅನ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ, d m ಅನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. So that means we can express n as a multiple of d. ಈಗ for example 3 divides 12. So that means 12 can be expressed as multiple of 3, that is 12 is equal to 3 into 4, like that, right? So here we can express n as a multiple of d, so which implies that n can be written as n is equal to, so d into some integer, you say some q, and m is equal to d into some integer p. So then definitely these numbers p and q are relatively prime. ಅವ್ರು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಡಿ ಜಿ ಸಿ ಡಿ ಆಗೋದಿಲ್ಲ. ಓಕೆ, ಯಾಕೆ ಅಂತ ಬೇಕಾದ್ರೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ನೋಡಿ, ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ವೇಸ್ಟ್ ಮೈ ಟೈಮ್ ಫಾರ್ such things. So you already discussed that in number theory. Okay, so if you want, ನೀವು ನಂಬರ್ ಥಿಯರಿಗೆ ಹೋಗಿ ಸ್ವಲ್ಪ ನೋಡ್ಕೊಳ್ಳಿ ಅದನ್ನು. Okay, where p and q are relatively prime. So where p and q are positive integers with GCD of PQ is 1. That means they are relatively prime. They are relatively prime. Now, a to the power of m is this one. I am taking a to the power of m whole to the power of k is equal to e. What it implies, a to the power of mk is equal to e. As we already know that order of a is n. Order of a is n. A to the power of n is equal to e. A to the power of mk is e. So definitely n divides mk now. So which implies that n divides mk. So here I am using the first property of the order of an element. Use the first property. What it is, just we show the property now. Yes, what it says, order of every element of a finite is finite and less than or is equal to order of, not this one, I think third property. I'm using third property here. So order of a to the power of k cannot exceed 10. Actually, I'm written that in note. Order of a to the power of m is e, then order of a is less than or is equal to m. Otherwise, you remember this point, that is so order of ಇಷ್ಟು ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ಆರ್ಡರ್ ಆಫ್ ಎ ಎನ್ ಇದ್ರೆ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಇ ಬರೆಯುವುದು. ಓಕೆ, ಯು ಕ್ಯಾನ್ ರೈಟ್ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ. ಸೊ ಅಗೇನ್ ಇಫ್ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಮ್ is also e, then definitely n divides m. Definitely n divides m. I'm using the same property here. A to the power of mk is also e, so which implies that n divides mk because order of a is equal to n, and this, so by the property I am using that property here. Okay, so n divides mk, which implies that what is n? We written that n is dq. N is equal to dq. So therefore dq divides mk, which implies that dq divides what is m? M is dp. dpk. So dq divides dpk. We can cancel this d and d. What we get? So then we have q divides pk. But p and q are relatively prime. ಅವೆರಡರದ್ದು GCD 1 ಇದೆ. p q ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ, q p ನ ಡಿವೈಡ್ ಮಾಡಲ್ಲ. ಓಕೆ, ಸೊ q and p, q never divides p, so but q divides p into k. That means q pk ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ q p ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು, ಇಲ್ಲ q ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಬಟ್ q not divides p, so then definitely q divides k. So which implies that q divides k because p and q are relatively prime. Okay, so q divides k. You take this is 1. Okay, again consider a to the power of m. Consider this a to the power of m whole to the power of q can be written as a to the power of mq, which is equal to a to the power of mq, which implies that a to the power of m whole to the power of q is equal to a to the power of mq. What is m? M can be written as dp, a to the power of dpq, which is equal to a to the power of says here by clubbing this d and q, you can write it is a to the power of dq to the power p. Or in other words, use this one. ಇದು ಯೂಸ್ ಮಾಡಲೆ you write this is a to the power of dq, a to the power of dq and yes, a to the power of dq whole to the power of p. This is equal to a to the power of what is dq. Yes, we consider that dq means it is n, so you write it is a to the power of n whole to the power of p. What is a to the power of n? A to the power of n is e, so it is e to the power of p means it is e only. This is because a to the power of n is e, order of a is n. Okay, so a to the power of m whole to the power of q is equal to e. So a to the power of m ಗೆ ಪವರ್ ನ q ತಗೊಂಡಾಗ e ಬಂದಿದೆ ಅಂದ್ರೆ ಅರ್ಥ what it indicates. So now order of a to the power of m, order of a to the power of m, a to the power of m whole to the power of q is equal to e. E means order of a to the power of m is less than or is equal to q. It is less than, so order of a to the power of m. Otherwise you write like this, order of a to the power of m. Yes, actually we consider it is k, and a to the power of m whole to the power of q is e. What it implies? ಈಗ I already told you this. Order of a is n. So you can write a to the power of n is equal to a to the power of m. This is the another integer. ಅದನ್ನು ಹಾಕಿದಾಗ e ಬಂದಿದೆ ಅಂದ್ರೆ then definitely n divides m. So similarly here order of a to the power of m is k. But when you put the power of a to the power of m is q, then it gives e. So then what it implies? Then definitely k divides this q. So which implies that k divides q. Okay, so take this inequalities 2 from 1 and 2. We get what this 1 is. Q divides 1, q divides k, q divides k, and k divides q. So it is possible only when they are same ಅಲ್ವಾ. ಒಂದು ನಂಬರ್ ಇದೆ, ಅದು p ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ, p ಆ ನಂಬರ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. ಅಂದ್ರೆ ಅವೆರಡು ನಂಬರ್ಸ್ ಏನಾಗಿರ್ಬೇಕು, ಈಕ್ವಲ್ ಆಗಿದ್ರೆ ಮಾತ್ರ ಸಾಧ್ಯ. ದಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಓನ್ಲಿ ವೆನ್ ದೇ ಆರ್ ಈಕ್ವಲ್. ನಂಬರ್ ಥಿಯರಿನಲ್ಲಿ ಹೇಳ್ತೀವಿ, if a divides b, b divides a, so it is possible only when a is equal to b ಅಂತ. That same concept I am using here. Q divides k and k divides q, which implies that k is equal to q. K is equal to q. So which implies that thus, so n is what? N is equal to dk. N is equal to actually dq. We take that n is equal to initially what is n is? N is equal to dq. N is equal to dq, which is equal to dq can be written as k because k is equal to q. Okay, so n is equal to dk, or you can write it is k is equal to, k can be written as k is equal to n divided by d. But what is k? K is considered as order of a to the power of m ಅಲ್ವಾ. ಆರ್ಡರ್ ಆಫ್ ಎ ಟು ದಿ ಪವರ್ ಆಫ್ m ಅಂತ ಬರೀಬಹುದು k ನ. ಯಾಕೆ ಅಂದ್ರೆ we take that order of a to the power of m is k here. Order of a to the power of m is k. So you can write order of k can be written as order of a to the power of m is equal to n divided by d. So order of a to the power of m is k. K can be written as n by d. So order of a to the power of m is equal to n by d. So actually that is the required result. So we need to prove that order of a to the power of m is n divided by d. So like that we find the order of a to the power of m when we know order of an element a. Okay, so these properties are important, hope you understand. So repeatedly, if you are not understanding first time, repeatedly look into the properties. I know some properties are difficult, but groups topics are like this only. So in future we are using all these properties to prove the further results in higher classes, okay, in rings and related topics. So but groups is as a B.Sc students you must be good in groups and rings in algebra. Totally you should be good in uh, algebra. So then mathematics will be easy in future. If you wanted to do master degree or PhD or something else, you wanted to achieve something else in mathematics, then definitely it helps you. Thank you. We'll discuss some more topics in next coming classes.